The normal pH of blood is between 7.35 and 7.45. Acidosis is a condition where blood pH falls below 7.35, and alkalosis is a condition where blood pH is higher than 7.45. A major physiological effect of acidosis is the depression of the central nervous system through depression of synaptic transmissions. If the systemic blood pH falls below 7, depression of the nervous system can be so severe that a person becomes disoriented, then comatose, and will probably die. Patients with severe acidosis usually die while they're in a coma. A major physiological effect of alkalosis, on the other hand, is overexcitability in the central nervous system and the peripheral nerves. Now, the neurons are going to conduct impulses repetitively, even when they're not being stimulated by the normal stimulus. So the results are nervousness and muscle spasms and convulsions and, again, possibly death. A change in pH that leads to acidosis or alkalosis can be balanced by compensation, which is a physiological response to acid-base imbalance that acts to get pH back to normal. The compensation is considered complete if pH is brought back within the normal range. It's considered partial if the blood pH is still lower than 7.35 or higher than 7.45. If a person has altered blood pH due to metabolic causes, then the respiratory system, through hyperventilation or hypoventilation, can help bring pH back toward the normal range. This form is called respiratory compensation, and it occurs within minutes, reaches its maximum effect though within a few hours. If a person has altered pH due to respiratory causes though, then renal compensation, or changes in the excretion of hydrogen ions or the reabsorption of bicarb ions by the kidney tubules, can help reverse the change in pH. Renal compensation can begin within a few minutes, but it typically takes a few days to reach its full effectiveness. So if one system, respiratory, is causing the changes in pH, then the renal system will try to change to compensate to get pH back to normal, and vice versa. Respiratory acidosis and respiratory alkalosis are disorders that result from changes in the partial pressure of CO2 in the blood. Metabolic acidosis and alkalosis are disorders that result from changes in bicarbonate ion concentration. So let's look just briefly at some examples of this. Respiratory acidosis is when you have an abnormally high partial pressure of CO2 in the blood. Inadequate exhalation of CO2 can cause the blood pH to drop, but any condition that decreases the movement of CO2 from the blood to the alveoli of the lungs so we can exhale it to the atmosphere causes a buildup in CO2, which leads to a buildup in carbonic acid and hydrogen ions. This can include emphysema, pulmonary edema, injury to the respiratory center in the medulla, airway obstruction, or even just disorders that affect the muscles that are involved in breathing. The respiratory problem, if it's not too severe, the kidneys can help raise the blood pH back to the normal range by increasing the excretion of hydrogen ions and the reabsorption of those bicarbonate ions. So that's renal compensation. In respiratory alkalosis, the blood pH, or the blood concentration of CO2, falls. So we have too little CO2. The drop in CO2 and the increase in pH is hyperventilation, which causes conditions that stimulate the respiratory group in the brain. So conditions such as oxygen deficiency if you're in high altitudes, or pulmonary disease, stroke, anxiety. Renal compensation is going to try to bring the pH back into normal range if the kidneys are able to decrease the excretion of hydrogen ions. Okay, so decreasing the excretion of hydrogen ions, what does that tell you? If we're decreasing the amount of hydrogen ions that are getting into the filtrate and into the urine, then we're retaining those hydrogen ions. And what is that going to do? that's going to drop our pH back toward the acidic side of the scale and get us back to normal. Treatment consists of increasing the level of CO2 in the body. Again, if you increase CO2, you're going to increase carbonic acid. In cases where respiratory alkalosis is caused by severe anxiety, you simply get upset, there's a very simple treatment. You simply breathe, inhale, and exhale into a paper bag for a few minutes. As a result, you're rebreathing that CO2. By increasing the level of CO2 in the blood, you restore pH back down to the normal levels by increasing that CO2. Sorry, I was moving ahead in my brain. My brain was headed into metabolic acidosis and alkalosis before I was ready. Now we're ready. So metabolic acidosis, the systemic blood pressure drops. Okay? So it causes the pH to decrease. There's a few situations that can lower the blood levels of bicarbonate ions. Actually losing bicarbs. Now remember, if you lose bicarbs, you have excess hydrogen ions, therefore acidosis. So if you're losing bicarb ions, such as what might happen with severe diarrhea, or if you have renal dysfunction, or you're accumulating excess acids other than carbonic acid, such as your body is in ketoacidosis, or the failure of the kidneys to excrete hydrogen ions from metabolism or dietary proteins. If the problem's not too severe, hyperventilation can usually help bring the blood pH back into the normal range, and remember that's respiratory compensation. Treatment, though, may consist of intravenous solutions of sodium bicarbonate to get more bicarb ions back into the blood. In metabolic alkalosis, the levels of bicarbonate are too high. A non-respiratory loss of acid or excessive intake of alkaline drugs, too many Rolaids. The pH increases above 7.45. Excessive vomiting of gastric contents can result in the loss of a lot of hydrochloric acid. It's probably one of the most frequent causes of metabolic alkalosis. Other causes include gastric suctioning, have to have the contents of the stomach suctioned out, the use of certain diuretics, endocrine disorders, excessive intake of antacids, Rolaids, and other things that you take for heartburn or indigestion, and also severe dehydration. Respiratory compensation through hypoventilation can bring blood pH back into the normal range. Treatment usually consists of giving fluid solutions to correct chloride, potassium, and other electrolyte deficiencies, plus also correcting the cause of the underlying alkalosis. In a lot of cases, you can determine what's causing an acid-base imbalance by doing a blood chemistry evaluation of three factors. Excuse me, pH, the level of bicarbonate ions, and the CO2. Each of these have normal values. So first thing you do is look to see whether the pH is high, alkalosis, or low, acidosis. Then you decide which value, the CO2 or the bicarbonate, is out of the normal range. And that could be the cause of the pH change. For example, if the elevated pH could be caused by low CO2, so elevated pH, that's taking you toward alkaline, right? So low CO2, less carbonic acid, less hydrogen ions, elevate pH. Or it could be because you have an accumulation of bicarbonate ions. Bicarbs are alkaline. That also is going to elevate your pH. If the cause is a change in the partial pressure of CO2, the underlying cause is respiratory. Remember, the respiratory system is how we get rid of CO2. If the cause is the change in pH is due to the change in bicarbonate ions, then the problem is metabolic. So you look at these values and you determine which one doesn't correspond with the pH change. So if you have acidosis and you have and increase in CO2 is acidosis, then that is respiratory acidosis. If you have acidosis, acidic pH, and your bicarbs are low, then that is metabolic acidosis because you don't have enough bicarbonate ions, the value is low, to buffer the hydrogen ions. All right, so in my class, I know you're going to have to work a few pH balance problems. It may be something that's just a handout in your class, or it may be something that we do in class, but this will help you to understand how to look at these acid-base imbalances and to determine what the cause is and if compensation is occurring. Remember, if compensation is occurring, the system that is causing the pH imbalance is causing the pH imbalance. The other system, either renal excretion or retention of hydrogen ions and bicarbs, or the respiratory system retaining or getting rid of CO2, will try to compensate for the system that is causing the problem. So if it's respiratory acidosis or alkalosis, then the renal system tries to fix it through compensation.